Today we are joined by Jocelyn Doucet, the CEO of Pyrowave. Today we will be talking all about their microwave technology and its application in the market as well as the future of technology.
Hello, my name is Jocelyn Doucet. I'm the CEO and founder of Pyrowave.
Can you briefly explain what Pyrowave does and the impact your work has on issues, such as climate change?
Pyrowave is a technology company. We've developed a proprietary technology using microwaves to break down plastics back into their root chemicals. So we use electricity and clean technology to recycle plastic back into what we call the monomers. And when you reset it back to the monomer form, you can reintroduce it in a variety of different products. It could be the identical plastic that you've started from, or you can do new products that include that monomer part of it.
What impact does that have on the environment then?
Well, the issue of plastic waste is growing, and so we've never consumed as much plastics as we're consuming right now. I think we're reaching up to 400 million ton a year. That's the global consumption of plastic. And the great advantage of plastic is also a strong disadvantage, is that it does not degrade over time, so it has a long lifetime. And so you need to find a way to be able to extract the value from that material and tackle the plastic waste problem. So that's one aspect of what we do for the environment. And on the other side, manufacturing of plastics is always using energy, it's using crude oil, and it's using non-sustainable resources. And so if we're able to use end-of-life plastics to make new plastics or other products, then we're also addressing this sustainability problem of fossil-based resources. And so at the end of the day, what that means is that we're able to take plastic waste, apply it into our proprietary technology, use renewable electricity, minimize the carbon footprint of whatever comes out of it, and we're able to reuse it into virgin application. So that's what we do for the environment, and it took us about 10 years to get there.
Can you talk briefly about the solutions that were previously used to recycle plastic and how your company has built on this?
Yeah, I mean, plastic has been around for more than 50 years, so this really started, getting into our lives in the 50s. And I think the advantage of using plastic is widely acknowledged. Like it's good for food preservation. It's good for from a weight perspective. So it has a lot of advantages. But until now, a lot of the end of life solution was about around mechanical recycling. So typically, this is what most people know. Like you put your stuff into the blue bin, it's being collected by a truck, and then it goes into a sorting facility. And what they do there is really physical, mechanical separation. So you have first of all, you have the different material apart from plastics. You have paper, metal, glass, and plastic. And this is what they do in what we call the municipal recycling facility. And then you separate all these raw materials, and then you have to do a second step where you differentiate the different types of plastics, because there are many types of plastics. You have polyester, like the bottle, but you have also polypropylene, which is some other parts of plastics, and you have polystyrene, which is specifically what we address. And so you have sophisticated equipment that's able to differentiate, and then you would wash and dry them, and then eventually grind them into and form flakes with it. So that's what we've been doing for many years. But there are limitations to this, and obviously the contamination is a big problem. You have additives, pigments, dyes. When you buy a container, there are pigments in it. It has a color in it, and it's very difficult to remove that color if you just do traditional mechanical sorting and recycling. So that's where the need for more what we call advanced recycling technologies it became more central in the past decades, because now we want to be able to move from a 7% recycling rate to a much bigger number, because we have a lot more plastic to process, and therefore we need to develop new technologies to do it.
Could you just briefly explain what is your microwave technology?
Sure. We do have a very differentiating technology here. We use microwave technology to break down the plastic structure and recover the monomers. So this is different from other technologies, but essentially we use microwaves to transfer the energy to the reactor. This is our proprietary reactor. And the advantage of this is that you can use 100% electricity. So what that means in the end is that we're able to use renewable energy that's being produced by renewables and now use that for manufacturing chemicals. The thing is, historically, the chemicals are produced by century-old processes. So basically, these processes are based on design design assumptions that are a century old. And so basically they use thermal energy to power the processes. And so if tomorrow morning you want to use renewable energy into chemical production, it's not it's not that easy. So you need a new set of technologies, and this is one type of technology that we want to use to manufacture cleaner and better product using electricity and eventually using microwave at a bigger scale.
So would you say that microwave technology is more sustainable in like the climate change?
I mean, it always depends on the cleanliness of your electricity. I guess at the end of the day, if your electricity is produced by a carbon, like a coal plant, then obviously you're going to have a lower impact. But eventually, what we're enabling with this technology is that you can use electricity to make chemicals, and that means you can now use also renewable energy, which is not possible right now with the existing processes that we see in the industry.
Is there a differentiation between chemical plastic recycling with the microwave technology?
Well, basically, chemical recycling, you have like three main families. You have what we call physical chemical processes where people dissolve, where they're going to use dissolution processes to remove the pigments and additives that are embedded with the polymer. So this is one set of technology, and then you have the thermal processes like our process using pyrolysis technology. So basically, we heat up the molecule to a point where it starts breaking out into smaller molecules. So you have traditional pyrolysis, and what we do here is microwave pyrolysis. And then you have the third family of technologies that are more chemolysis, where they use additives or chemicals to break the structure. And this is more applicable for like polyesters and nylon, for example. These are condensation polymer, we call them. This is very suitable for this type of chemolysis. But for what we call thermoplastics like polystyrene, polypropylene, thermal pyrolysis is the way to go. But there are different types of pyrolysis in the market. You have catalytic pyrolysis, you have fluidized bed catalysis, twin screw pyrolysis, and what we offer is microwave pyrolysis. And we claim that we have much better yields. So for each kilogram of input that we put in our system, we get 1 kilogram of liquid, which is high value added and can be used in making other products, which is not the case with other technologies. So this is really a disruptive technology in the sense that we're bringing to the market a new technology using microwaves that has a significant advantage over other thermal-based chemical recycling technologies.
So I guess microwave technology is just like a subset of chemical recycling, right?
Exactly. You have like chemical recycling is a broad term that englobes a variety of different technologies. Microwave pyrolysis or microwave recycling is one of those technologies, and this has been pioneered by us. And we didn't reinvent the wheel really. I mean, this is there's a lot of science that was published back 30 years ago using microwaves as a vector for converting plastic into chemicals. But the challenge was being able to scale it up and get it up to the commercial level. And this is what we've achieved in the past 10 years.
Can you explain the benefits of your technology and how it can help in developing a low carbon manufacturing industry?
Sure. I mean, so the great advantage of, so essentially the know-how we developed at Pyrowave is how to use microwaves at a large scale to do chemical reactions. And our first application, very successful application, is converting polystyrene waste back into styrene monomer. This is what we do now, and we have a couple of partnerships with key clients, and one of them is Michelin. They're based in France. It's the famous tire company. And we do with them is that we turn polystyrene waste into styrene monomer, and styrene monomer is used by Michelin to make elastomers. So the rubber that you have on your tire, part of it contains styrene monomer. And Michelin's goal is to turn sustainable on every type of feedstock they use in their products. So one way to do that with styrene is to use polystyrene waste to make renewable styrene. But we can go beyond that because the real power of our platform is using microwave for chemical production, and there are multiple other applications that we work on as well, whether that be in the composite recycling. So a lot of composite material are accumulating all over the world, and then we claim we have one solution to address that. But it can also go into other applications like cement. So cement production is a massive contributor to greenhouse gas emission, and with our platform we're able to manufacture Portland cement using microwaves instead of burning coal in big kilns, and therefore we're able to perform to deliver cement with significantly lower carbon footprint than you would otherwise get with standard process.
What do you think the future of chemical recycling looks like?
Well, I think the future of plastic is strongly linked to the success of chemical recycling. I think history has shown that for the past 50 years with mechanical recycling only, there are huge market limitations. It's very difficult to sell the output of a mechanical recycling facility because it doesn't match virgin quality, because it's, you have some quality issue, you have a whole bunch of things like that. Now, you need to get to a different level of recycling, and to me, it's pretty similar to what you see in a refinery, like the current petrochemical industry. I mean, for me, plastic waste is like the crude oil, all right? Crude oil is the raw material to make other products, and you need in between several types of operations to get it to a point where you can use it into finished goods. The first step is refining, and for me this is what the mechanical recycling is doing right now. So removing all the big impurities, removing the different foreign material, and have different cuts of different products, different types of polymer that can now be fed into what we call downstream operations, like in the refinery, where you can do other stuff like monomers, like fuels, like various other products. So for me, this is the real petrochemistry of the future. And I think the success of that petrochemistry of the future will be, determinant to the future of plastic in our lives, because I don't think we can really continue piling that much material in our ocean, in our soil, and expect the world to be, going better. So I think we need to have these solutions to be put forward, and I think the success of these technologies will be determinant to the plastic industry.
How significant is Pyrowave's participation in Chemical Recycling Europe in supporting future European projects?
Pyrowave joined Chemical Recycling Europe last year, and we think Europe is a fantastic market to enter because of this leadership in policies that support integration of recycled content into new products, that creates a market for recycled products. And it also is where you have the most companies with long-term sustainability goals, and that means also integrating in their own value chain recycled materials. And this is what is the driver for adopting chemical recycling technologies. And so our implication with Chemical Recycling Europe was really driven by this leadership that Europe is showing worldwide, and sustainable economy and circular economy of plastics.
Do you think your technology, so like microwave technology and also chemical recycling, do you think it will help to facilitate the net zero by 2050?
Well, becoming net zero is a tough challenge. There's always emissions somehow, through transportation, through byproduct treatment. When we look at our life cycle assessment, you realize that, okay, it's one thing to turn plastic back into root chemicals or useful chemicals for the industry, and you can do it with very low carbon footprint. As a matter of fact, if you use nuclear power or hydropower or windmill power, you have almost zero emission. However, the supply chain before and after will still, emit greenhouse gas emissions. So becoming net zero is a very ambitious challenge, but I think there's a lot of room for doing better, at least reducing the carbon footprint. I mean, our life cycle assessment shows that depending on where you apply the technology, you can have anywhere between 50% to 65% reduction in greenhouse gas emission. So when you multiply that number to a huge industry, 400 million ton a year, that's a lot of material to start with. So that's already a good start. But yeah, I mean, do we need to fix and set ambitious goals so that the industry moves in the right direction? Probably. But becoming net zero is a very challenging it's a very challenging goal for sure.
What do you think the type of goals will look like to achieve, well, not net zero by 2050, but a more greener environment?
Well, I think first being conscious of the natural resources that we consume. So when we look, for example, at our life cycle assessment, greenhouse gas emission is one thing for sure. But we also need to look at, natural resource usage, water usage, several other indicators. At the end of the day, I think greenhouse gas emission is a good indicator, but um, you know, when we're breathing, we're also emitting greenhouse gas emissions. So it's somehow greenhouse gas, carbon dioxide is part of a process. As long as we find the balance between what we can emit and how much can be captured, I mean, this is going to work. But at the end of the day, I think we need to also have sustainability goals looking at water use, land use, natural resource use, and this is all part of the circular economy as well. Like if you're able to reintroduce the material after its end of life and return it back into new products, and there's an energy cost and there's a carbon cost, but at least you're able to reuse it, I think is already an improvement. So I think my comment would be to not just look at the greenhouse gas emission indicator, because there are many other indicators to look at. But if we make a significant improvement on greenhouse gas emission, because that's the most pressing issue at the moment, and we're making significant progress on that front. Even if we're not having net zero, at least if we're progressing on other indicators as well, that's already a significant improvement.
What are your thoughts regarding technology no longer being anchored in science?
We believe that all new technologies need to have a solid science background. At Pyrowave, we do have a very solid team of engineers, chemists. I'm a chemical engineer by training as well. And so we've always been driven by innovation, but by making sure that we have strong roots into science. And so we publish articles. We've published a chapter in the Handbook of Chemical Recycling last year, published by the American Physical Society. So we like to make sure that everything has been, all the numbers add up, because right now there's a lot of skepticism in the chemical recycling industry because there are different technologies out there. There's a lot of expectations being set up by different companies, and that is also a combination of the fact that you have new technologies, but you also need to find the proper investors and the proper partners. And sometimes a lot of companies will set high expectations to be able to attract clients or attract funding and whatnot. But we don't play in this water. We prefer to have realistic expectations and make sure that we progress on the science with the right pace. And I think it's paying off right now, because we do have now a technology that's truly differentiating, that is significantly better than any other in the market right now. And we have strong roots and strong investors, strong partners. And so I think we're in a position to really roll out our technology in the next decades.
Do you think chemical recycling is sustainable?
Well, asking if chemical recycling is sustainable is like asking if a car is sustainable. It depends on the type of car. And I think it's the same thing here. It depends on the type of chemical recycling. I think, like I said, there are multiple indicators to look at. Like What's the yield of the technology? What's the energy consumption? What's the carbon footprint? What's the impact on the different indicators? And one thing that we work really strong on here is defining the proper framework to report environmental footprint or environmental impacts of the different chemical recycling technologies through life cycle assessments. So it's one thing to have life cycle assessments, but how do you compare multiple chemical recycling technologies amongst themselves if they offer a different value proposition? I'll give you an example. If you compare what we do, microwave recycling, with mechanical recycling, we're not rendering the same service because the output is not going to be used for the same applications. So sometimes you're going to see different life cycle assessment being compared, and they're going to compare different technologies that are not necessarily doing the same service, or they're not making the same output. And so this is where there's a lot of complexity, and a lot of people are working on this, and we're actively involved in this debate. And at the end of the day, I think chemical recycling can be good for the environment, can have some strong benefits, but like anything else, like it depends on what's the input, where is it coming from, what's the performance of the technology, how much energy, how much carbon footprint, and so on and so on, how much water is it using. This is, it's when you look at all the aspects of the picture that you can really make yourself a clear idea. But it's a complex issue. They're complex technologies, and they fit in a complex value chain, and you need to understand every element of the value chain to be able to really assess whether this application makes sense or not. And that's why I think I'm going to use something that most people say there's no silver bullet, but that's true here. I mean, it really needs to take into consideration every aspects of the value chain and the specific technologies involved.
So, what other solutions does Pyrowave have at your company? Like other solutions and technologies have you guys employed?
Our technology platform is the ability to use microwaves at industrial scale. So, you know, theoretically, anything you can do with microwave at the lab scale, we can do it industrially. We can scale it up. Our primary application is really turning polystyrene waste. So think of all the yogurt cups, like all these things, styrofoam, we can turn it back into styrene monomer. Styrene monomer is used for electronics, computer screens, tires, a whole bunch of products that most people don't even suspect there's styrene in it. So this is a globally traded commodity, and it's present in many products that we use. So this is our core application, turning polystyrene into styrene monomer. But we have like other applications that are in the pipe right now. One of them is the composite recycling. So lots of windmill blades, aircraft composites. These are all elements that we're focusing on in the next steps. So our technology is very, very good at recycling composites. And the other thing that we're looking at is the cement, low carbon cement production. Cement is the second largest carbon emission sector, and we like to have impact at Pyrowave. So one of the applications that we're looking at is really a moonshot because it's such a big opportunity. And being able to use microwave to calcinate limestone to form cement is one of our other projects that we're looking at. So you see this platform, technology platform, is fantastic, and I think our future is really bright because there's a lot of challenges moving forward in decarbonizing our industry, and that's why our focus is to use electricity to make better product with lower carbon footprint.
Do you think the market is ready to implement your solutions?
I think the market is ready to adopt new technologies when they see the value added. And some of the early adopters that we've worked with, initially they were looking to keep their right to play in the market. So some people making products, and now they have new policies, or they foresee new policies or regulation coming in the market, and they want to keep their right to play in that market. So this is what drives the early adopters. But then after that, pretty quickly, you need to show that there's value in using your technology. And we clearly see it in the styrene business, like turning polystyrene into styrene. There's a lot of advantages in making styrene from waste rather than making styrene from crude oil and natural gas. So there's a value added in doing it, not only on a carbon credit perspective, but also from a, from a balance sheet perspective. Like you can make styrene at a lower cost right now with our technology than you would do it with virgin fossil resources. And this is because market, crude price is going up and down so often, and so sometimes in some period of the market you will make some money with virgin resources, but in other cases you will not. But with this new technology using plastic waste rather than, you know, time sensitive commodities, then you can have a better visibility on the pricing of your product.
Does Pyrowave have any other exciting projects coming up that you would like to discuss?
Well, we have a couple of great news coming in the fall, but one for sure, what's keeping us very busy is our partnership with Michelin in Europe. So we will make hopefully announcements coming in the next weeks about this project in Europe. So that will be the first, industrial scale showcase of our technology in Europe. We have a couple of other projects coming up in Asia that hopefully we can announce shortly. And I think for me, this is a strong signal that now the industry is moving forward. It's not even it's a no-brainer to them now that they need to move into this new economy, circular economy, and so adopting new technologies that really have a differentiating element, like our technology using microwave low carbon footprint to make better product with lower carbon footprint. To me, that's the future, and I think that's just the starting point of a fantastic journey.